Can you hear me and see my screen?
Yeah,
all right,
perfect.
All right. First of all, good morning, everyone. And I would like to thank the organizers for inviting us to represent Nfdf FChem and also speak a bit more about the terminology service that we are currently building as a part of NFDI's infrastructure. Before I start, I would like to introduce myself. I'm Chandu Nainala. I'm currently leading the software development team under the Christoph Steinbeck here at ENA, Germany. And previously, before joining the NFDI for Chem team, I was working with metabolites. I led the team there in European Bioinformatics Institute based in Cambridge, UK. In today's presentation, I'm going to be introducing NFDI for Chem to you and also talk a bit more about the vision, strategy, and also the resulting services that we are planning to build in the near future. In the latter half of the presentation, we have Philipp Stroemert from German National Library of Science and Technology. He'll be presenting about the terminology service, which is a key component of NFDF FChem that enables research data interoperability, discovery, and exploitation, especially in the areas of chemistry. So what is NFDF FChem and who are we actually? So NFDF FChem is an initiative to build open and fair infrastructure for research data management in the area of chemistry. From its very beginning, and is still, it's a grassroots movement, along with the scientific needs of growing along with the scientific needs of the community. The consortium is built on three equally important pillars. First, the learned societies like the German Chemical Society and its divisions, the Bunsen Society for Physical Chemistry and the German Pharmaceutical Society. Second, the information infrastructure institutions like the TIB, FIC, SCC, and others. And third, but the most important, is the broad diversity of the university and non-university institutions representing the scientific community and many subdisciplines of chemistry. Altogether, NFDF FChem covers the whole spectrum of data producers all the way to the data consumers. As you know, chemistry have quite a number of subdisciplines and it generates a vast amount of data, not only in its own, but also as a science assisting other disciplines. We as a consortium, in order to maximize our impact, we have decided to focus on the molecular information, that is information about the molecules, their properties, and analytical data, both experimental and also computational simulations. Now that with the focus on molecular information, what kind of data are we actually looking at? As I mentioned, the scope of NFDF for Chem is molecular information, the characterization and the reaction data. Besides describing the research data sets with domain-independent core metadata like the ones defined in the data site, we will initiate the development of minimum information standards for majority of the fields in the field of chemistry towards domain-specific metadata or domain-dependent metadata. We would also like to broaden the perspective by including the contextual data and metadata from experimental simulations by capturing the roles of molecules as adducts or reagents or products. Along with that, we would also include the analytical data with the molecular information and of course the biological information as well. We aim not only to describe this information in a human readable format, but also make it more machine readable by applying controlled vocabularies, terminologies, and ontologies by semantically annotating the data, which I believe Stroemert will be discussing more in detail later. In this particular slide, I would like to join some of the members here in beating the drum against how unfair the current research data management principles are across the industry. The status quo in chemistry is that a lot of the data is still managed in an analog way, literally written with a pen in a laboratory lab notebook. Sometimes this might be the easy way of doing things, but this actually brings in a lot of data loss and other things, as I don't have to explain it in detail here. Data is, of course, digitally generated by analytical instruments like NMR and mass spec. However, the data is stored locally in data silos, and there is no integrated information flow there. And the most unfortunate aspect is that the way that data is published in the end, the chemical data published is in the form of PDFs or Word documents or photographs, where the original rich information is lost when published as PDFs or documents. This is far away from the fair data principles. Our vision at NFDF FChem is fundamentally different and is a quantum leap over the status quo. We aim to fully digitalize the entire data flow from the earliest time point in the laboratory all the way to the data publication based on open standards and tailor it to the community needs. Our strategy and approach for seamless integration of smart labs and repositories is based on the fact that we want to leverage the existing software and also build new software on top of this. The software developed will be based on open standards and metadata, as well as legal advices, policies, and terminology services. So in terms of seamlessly connecting the labs with the public journals, we use the term smart lab to define all the digital lab, electronic lab notebooks, and also the devices and the APIs in order to integrate that. And eventually this data will end up in repositories where it is archived and published. Of course, all of the data will be made available through a portal complemented with the knowledge base, help desk support, and teaching and training services. So this brings us to the topic of interest for today, that is the terminology service, which is a key aspect of NFDI for Chem in order to bring the rest of the components together by offering a single point of access to controlled vocabulary, terminologies, and ontology services. I would like to now hand it over to Philip in order to discuss more about the terminology service. Philip, over to you.
Thank you. Thank you, Chandu. Hello, my name is Philip Stroemert, and I'm working at the TIB in the task area that is focused on the use and development of ontologies. And as Chandu just mentioned, a big part of this is the terminology service itself, which hosts those ontologies that we need to work with. And as you can see in this slide, what is already publicly available is the backbone, which is made up of the ontology lookup service by the ABI. And we've implemented it and rebranded it a little bit, but we've also added a faceting feature, which allows us to sort the terminologies indexed in our terminology service into collections, which makes it easier to focus on certain domains or on certain use cases. For example, we could use this to put all terminologies used by a certain application into a named collection. And the terminology service itself is, for example, also a facet of a more general terminology service that is established here at the TIB, which indexes also terminologies used in other fields and by other NFDI consortia, like NFDI for Culture, for instance, and also by other TIB projects. And this faceting feature, as being part of an open source code, is also fed back into the OLS development. So hopefully this will be implemented upstream, and it is currently being revised. Next slide, please. Thank you. What you can also see here are the two core features that OLS provides out of the box, which on the one hand is the human interface to look up terminologies, and also there are single terms properties and classes in there, and also to see the metadata that describe these terminologies and terms to understand what the terminologies and ontologies are actually about, and how those terms and ontologies should be used if the metadata is present in there. On the other hand, you can see the other core function, which is the machine readable access point, so the API to let machines access the terminology service. And this is very crucial because we need this in order to build the rest of the infrastructure, as you have seen in this one slide from Chandu. So if we want to have electronic lab notebooks being able to use ontologies, we need such kind of API to query. And it's also, so this is useful for the prospective annotation of research data with ontologies, but it is also helpful if we want to do this retrospectively when we have a controlled single point of truth. So we need those two features, especially the second one, to address the goals of the NFDI for Chem project. So some objectives, which are the implementation of minimal metadata standards, but also the FAIR principles and the fostering of semantifying research data from the very beginning. Next slide, please. And also what you can see here is that the terminology service is not just the OLS and the indexing system itself, but what we are planning to do, what you can see here is kind of like a 3-pillar system, with the first pillar being the curation pillar, and the second one, the lookup and search, which I've just shown you, which is already available. And the third pillar, the publishing and archiving pillar. The first pillar is focused around the fact that we want to enable normal chemists to be able to make file requests. For instance, like there's a term missing in an ontology, it should be easy to file a term request throughout the from the terminology service into the upstream ontology without having to deal with GitHub, for instance. Or we also want to provide a platform that enables chemists to work together and curate terminologies, but also create new terminologies using tools like Web Protege, and under the hood also, of course, Git-based archiving systems like GitLab and GitHub. The second pillar you have seen, it's basically mostly based on OLS. But also we would like to integrate features like Readable, for instance, for visualization of the terminologies as well, to make it more human friendly. And the third pillar, of course, when we talk about publishing and archiving, we want to ensure the fact that if an application uses a terminology of a certain version, and that this version is persistently archived, so the application will function even though the terminology has been released with a new version. Next slide, please. So what you can see here is a lot of bullet points that we would like to accomplish, and what is highlighted in blue here is our current focus. So what you can see is, or what we have done already is index 21 existing ontologies from third parties, ontologies such as the CHMO or RxNO, the chemical methods ontology, or the named reactions ontology, the chem informatics ontology, cheminf, and of course ChemI, and many others. You can have a look and browse them, but I'm sure many of those you are probably familiar with. And if you find any missing ones that definitely should be in there, you can definitely file a request via the help desk email address we have provided. And we are also focusing content-wise on identifying new use cases that have not been dealt with in existing ontologies, and either trying to request terms if an ontology already covers this domain and scope, or if not, then we are also focusing on developing new ontologies together with domain experts. And with regard to the technical functions, as I've already mentioned, we have a lot of things planned, but most importantly, we would like to use the ontologies indexed in the terminology service in electronic lab notebooks like Chemotion, where the chemical methods ontology, CHMO, and the named reactions ontology, RxNO, is already used to select what kind of methods have been used in the lab, or what kind of reactions are being analyzed or have been used. And as I've said, also visualization tools are planned. What we have also already implemented when it comes to the indexing of terminologies is to make sure that a certain quality standard is there and is present. That is, for example, looking for certain kind of metadata like classification, license, ID, creators, and title, that everything like this is present, and that the license is also machine readable. But also we are checking the consistency of the terminologies using reasoners to make sure that we do not have inconsistent ontologies in the lookup service. And yes, we plan to add curation interfaces, as I've said earlier, to integrate all of this together. Yes. And I hope with this, I have given you a lot of food for thought. And if you have any questions, please ask, and please get in touch with us. Thank you.